This lesson is on modeling with conic sections. We'll do 3 problems on this activity, and we will do 3 problems on another video. Problem 1. By the way, these can be found in your packet. Problem 1, the cables of a suspension bridge are in the shape of a parabola. The towers supporting the cable are 600 feet apart and 80 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable from the road at a point 150 feet from the center of the bridge? One of the most important things that we need to understand when we are doing word problems is that you typically have to figure out where the origin and where your axes go. You can pick wherever you want, and it doesn't really matter. So if you wanted to make the origin over here, that would be completely fine, and you'd get the problem right. It just might make the problem a little bit harder in terms of where you are, how you write the equation. If you probably pick this point as the origin, that might make your problem a little bit easier. So when you are making your axes here, you have figured out that your parabola has its vertex at 0, 0 if you choose this particular set of axes. Obviously, you can do whatever you want, but this is probably the easiest way to go about this one. Then we also know that at the point 380 and the point negative 380, you have points on your parabola. It's 300, obviously, because if the length of the bridge's cables are 600 and you put the center at 0, then there's a distance of 300 in the x direction both ways. So we have the equation y equals ax squared, and the reason why you don't have any horizontal or vertical shifts is because you strategically picked the origin to be at 0, 0, and well, the origin's always at 0, 0, but you strategically picked the vertex to be at 0, 0, so this works out really well. So now we just substitute in values for y and x in order to find a from one of the points on the parabola. So a equals 80 over 300 squared. 300 squared is 90,000. So a equals 8 over 9,000 if you want to reduce. As a decimal, that's 0.0008, and then the 8 starts repeating. So if you write it as a decimal, it looks like that, but I would try to avoid doing that as much as humanly possible. So then you can get more exact answers. Now, in order to find the height of the cable from a point on the road 150 feet from the center of the bridge, you would put 150 in the place of x. And that means it is 20 feet. Now, could you have substituted in negative 150? Absolutely, because parabolas are symmetric. So 20 feet is the answer for the first one. Second one, 2 girls are standing in a whispering room, or a whispering gallery that is shaped like a semi-elliptical arch. The height of the arch is 30 feet and the width is 100 feet. How far from the center of the room should the whispering dishes be placed so that girls can whisper to each other? This is actually there are some pretty famous stories about whispering rooms, and how you might want to look them up, how kings made it so that they placed their throne in a place where they could hear what people were whispering to each other in another part of the room. So you might want to look that up a little bit. There's some interesting stories from European history about that. Again, you can set up your axes so that the center of the ellipse is at the origin. If the ellipse has a width of 100 feet, you would probably have intersections on the x-axis at negative 50 and 50. You could have done it on the y-axis too if you wanted. And since the height is 30, you'd have y intersections at 15 and negative 15. Obviously, that's not a very good drawing, but you can live with it. So our objective is to find the location of the focus. And so in order to find the location of the focus, we know that this distance from the intersection with the minor axis and the focus is equal to the length from the center of the ellipse to the intersection of the major axis. And so this is 15, that's 50, and our horizontal distance to the focus will be x. So we have 15 squared plus x squared equals 50 squared. X squared equals 2275, and when we take the square root, we get plus or minus. We would take the positive in terms of the answer because we're looking for a distance, 47.697 feet. So that would be the horizontal distance. If we wrote the equation, it didn't ask for it, but if we wrote the equation of this, it would be x squared over 50 squared plus y squared over 15 squared equals 1. So the answer to that is 47.697 feet. Finally, an ice rink is in the shape of an ellipse, and it is 150 feet long and 75 feet wide. What is the width of the rink 15 feet from a vertex? Once again, we would want to draw some axes. Your choice of axes is really important, not in terms of getting the problem right, but in terms of making the problem easy. So if we have 150 feet for the length and 75 feet for the height, we're looking at an ellipse that looks something like this. Our objective here is to find out, since we want to be 15 feet from a vertex, these are obviously our vertices in an ellipse. So we want something 15 feet from the vertex, and we want to find this distance. We want to find the distance from this intersection to this intersection vertically on our picture. So our job is to find out what y is. And since it should be symmetrical in terms of what the values of y are, once we find one of them, we know the other one's negative, and we can basically just double that length and get the answer. So our equation is x squared over 75 squared plus y squared over 37.5 squared equals 1. We would want to substitute in 60 for x. And then we have a little bit of solving to do. We want to solve for y, obviously. So if we multiply everything by 75 squared, we get 60 squared plus 4y squared equals 75 squared. If you multiply the y squared over 37.5 squared term by 75 squared, one thing to notice is that 75 squared is exactly 4 times what 37.5 squared would be. And if you want to check that, you can check any particular pair of squares. So 3 squared and 6 squared, if they are, if these bases are 2 times apart, then they would be 4 times apart after you square them. That's just something that you can check on your own. When we solve for y, we get 22.5 plus or minus, clearly. So we could have 60 comma 22.5 and 60 comma negative 22.5 as our points. Since we're looking for the vertical distance, we would take 22.5 minus negative 22.5, or just double 22.5, and we get 45 feet. So the width of the rink, 15 feet from a vertex, is 45 feet. You could check your answer by plugging 22.5 back in for y and seeing that when you had 60, it ends up working out and equals 1. And then that that seems to work for that particular problem. Please move on to the second video in the series of word problem modeling videos.